Welcome to EDU World Space.
Okay, so in first part of this problem, we are asked to find out how many milliliters of this much molar HCl are needed to completely neutralize 50 ml and this much molar barium hydroxide solution. So to find that, what we'll do first is find the number of moles for this volume and this molarity of barium hydroxide. From there, using the balanced equation for this reaction, we will find out how many moles of HCl which we need to neutralize that much mole of barium hydroxide. And from there, using the molarity and the calculated number of moles, we will be able to find out how many milliliters of HCl are needed to completely neutralize this. So first, we will find the number of moles of barium hydroxide. So number of moles of barium hydroxide will be equal to its molarity times volume in liter. So the molarity here is 0.11 molar or mole per liter times the volume in liter. We have 50 milliliter. So we'll write 50 times 10 to the power minus 3 liter. And from here, we will get a value of 0.005 mole. So this is the number of mole for the barium hydroxide. Now we will write down the balanced equation for this reaction. So the balanced equation, we are writing it, the balanced equation directly, which will be 2HCl will react with 1 barium hydroxide to give us barium chloride and 2H2O. So from the balanced equation, we can see that 1 mole of barium hydroxide will react with 2 mole of HCl. So we will write 1 mole barium hydroxide will be neutralized by or will be identical to 2 mole HCl. That means 0.005 mole barium hydroxide will be neutralized by 2 times 0.005 mole HCl, which is equal to 0.01 mole HCl. So this is the number of moles for HCl which will be needed. So from here we can find the volume of HCl needed using the molarity. So the volume of HCl needed will be number of moles of HCl over its molarity. So we know that we just calculated the number of moles as 0.01 mole, and the molarity is given as 0.120 molar. So we will write it as 0.120 mole per liter, and this will give us a value of 0.083 liter, and we need to find out the answer in milliliter. So we'll convert this to milliliter. 1 liter is 1000 milliliter, and from here we'll get 83.3 milliliter. So this is the volume of HCl in milliliter which will be needed to completely neutralize this much barium hydroxide. Now we will go to our next problem. So in this problem, we are asked to find out how many milliliters of 0.1 to 5 molar sulfuric acid are needed to neutralize this mass of sodium hydroxide. So again, what we will do, we will find the number of moles of sodium hydroxide for zero point 0.2 gram sodium hydroxide, and from the balanced equation, we will find how many moles of H2SO4 we will need to completely neutralize this much mole of sodium hydroxide. And from that number of mole of sulfuric acid, using this molarity, we can find out the volume in milliliters for sulfuric acid. So first we'll find the number of moles of sodium hydroxide, which is mass over molar mass. So the mass here is 0.200 gram, and the molar mass of sodium hydroxide is 40.01 gram per mole, and it will give us a value of 5 times 10 to the power minus 3 mole. So this is the number of mole of sodium hydroxide. Now we will write the balanced equation for this reaction. So the balanced equation will be H2SO4 in aqueous will react with 2 sodium hydroxide to give us sodium sulfate and 2H2O. So now from here we can see that 2 mole of sodium hydroxide will be neutralized by 1 mole of H2SO4. So 2 moles sodium hydroxide will be neutralized by or will be equal to 1 mole H2SO4. That means this much mole of sodium hydroxide will be neutralized by 1 over 2 times 5 times 10 to the power minus 3 mole, and this will give us a value of 2.5 times 10 to the power minus 3 mole. So this is the number of mole of sulfuric acid which will be needed. So now from this value and using the molarity, we can find out the volume of sulfuric acid needed. So BH2SO4 will be number of moles of H2SO4 over the molarity of H2SO4, and the number of moles we have just calculated as 2.5 times 10 to the power minus 3 mole, and the molarity is 0.125 mole per liter. So it will give us a value of 0.02 liter. So we have to find out the value in milliliter, which will be again 1000 milliliter as 1 liter, give us a value of 20 milliliter. So this is the volume of sulfuric acid in milliliters which will be needed to neutralize the sodium hydroxide. Yeah. So the sodium hydroxide. Now, in third part of this question, we have to find out if this much milliliter of barium chloride is needed to precipitate all the sulfate ion in 752 milligram of sodium sulfate. What is the molarity of the barium chloride? So again, first we will find out the number of moles for 752 gram sodium sulfate. From there we'll find the number of moles of barium chloride, and then using the balanced equation we'll find out the molarity of the barium chloride. So first we'll find the number of mole of Na2SO4, which will be the mass over molar mass. So 752 milligram is 0.752 gram over the molar mass of sodium sulfate, which is 142 gram per mole. And this will give us a value of 5.3 times 10 to the power minus 3 mole. Now we have found the number of mole of sodium sulfate. Now we'll write the balance equation. So the balanced equation for this reaction is barium chloride reacting with sodium sulfate, giving us barium sulfate and 2NaCl. Now from here you can see 1 mole of sodium sulfate will be neutralized by 1 mole of barium chloride. That means this much mole of sodium sulfate will be neutralized by the same number of um, BaCl2 or barium chloride. So we can write down the number of mole of barium chloride as this. So in BaCl2, or the number of moles of BaCl2 is 5.3 times 10 to the power minus 3 mole. Now from here we can um, find out the molarity of barium chloride, which will be number of moles over volume. Number of moles is this one, over the volume is 55.8 milliliter. We'll write it as liter, just multiplying by 10 to the power minus 3, and this will give us a value of 0.095 molar. So this is the um, molarity of barium chloride solution. Now in last problem we have to find out if 42.7 milliliter of this much molar HCl is needed to neutralize a solution of calcium hydroxide. How many grams of calcium hydroxide must be in the solution? So again, what we will do first, we will find out the number of moles of HCl from its volume and molarity. From there, using the balanced equation, we will find out the number of mole of calcium hydroxide which will be needed, and then from that number of moles, using the molar mass, we can find how many grams of calcium hydroxide will be needed. So first we'll find out the number of mole of HCl, which will be the molarity times volume, and the molarity here is 0.208 mole per liter times the volume in liter, 42.7 times 10 to the power minus 3 liter, and this will give us a value of 0.009 mole. So this is the number of mole of calcium hydroxide. Now what we will do is we will find out the balanced equation. From there we will find out the number of moles of HCl required. So the balanced equation is 2HCl will react with 1 calcium hydroxide to give us 1 calcium chloride and 2H2O. Now from here we can see 1 mole of calcium hydroxide will be neutralized by 2 mole of HCl. 1 mole calcium hydroxide will be neutralized by or identical to 2 mole HCl. That means so we have find out the number of mole of HCl. So what we'll do is we'll write it down the other way. Two mole HCl will be needed to require will needed to neutralize 1 mole of calcium hydroxide. That means 0.009 mole HCl will be required to neutralize half times 0.009 mole, which will be equal to 0.004 mole. So this is the number of moles of calcium hydroxide which will be neutralized. Now from here we can find the mass of calcium hydroxide. So mass of calcium hydroxide will be the number of moles times the molecular weight. So the number of mole is 0.004 mole times the molar mass or molecular weight of calcium hydroxide, which is 0.296 gram per mole. And this will give us a value of 0.296 gram. So this is the mass of calcium hydroxide, which must be in the solution.